Today we're going to take a look at securing a web API with HTTP header client secret. First I'm going to navigate to spjeff.azurewebsites.net to generate a new web API from a template. Here we'll go ahead and give it the name Secure API and download classic zip. From that download we can open up the Visual Studio solution. Here we can see the Solution Explorer, including a default controller called Hello. This controller will echo back the current date and time, as we can see on line 25. Let's go ahead and hit F5 to play. Put it into Fiddler. We can see the project running on localhost 2069, and if we add /API/hello, we can see it echoing back the current date and time. If we copy that URL over to Fiddler and put it into the Composer utility, we can execute the same request, and we can browse the response as JSON. Here's the raw format, and here's the tree diagram. So this is great. We have a web API project up and running. Now we'd like to give it a HTTP header client secret as a way of securing the API. Now times when you might want to do this or the API is on the internet, you're not looking at a Windows integrated security model, so being part of Active Directory or Azure Active Directory, good options, and definitely look at those and explore those first. But for something that's maybe a little bit more convenient security, doesn't require nearly as much effort to configure, integrate, and prepare, one option we might consider is to add an HTTP header, and that client secret is required for the API to respond. I'll show you what we're talking about in a second. Right now, what we're sending is an HTTP GET with no security at all, and it's echoing back. So this is an anonymous API that anyone could access. We want to change that to make the API restricted to only certain users. First, we'll go over here to Visual Studio and we'll take a look at our key methods. So here we have IEnumerable and we have public string get. This is the method being invoked when we get the API today. And you can see there's other methods for other HTTP verbs. What we want to do is add a little bit of security to this. And we're going to essentially wrap this with an if statement that if we pass the authorization, execute the real method, otherwise return null. And so what we're trying to accomplish here is that there's a condition under which we will execute the code, that this is a valid request from a known user or known source. However, if it's a generic HTTP GET, it doesn't have that header, it doesn't have that client secret, we're going to return null and just ignore the request. Now to generate a client secret, we're going to go back to our web browser and look at grc.com. This is the Gibson Research Corporation, and they have a random password generator. We'll go ahead and reload the screen, and we'll pick out one of these random passwords. And go ahead and copy that and bring it back over to Visual Studio. And what we'd like to do is add a method that can be shared up here that's going to do our validation. We're going to call that function keyMatch. So up here we're going to add a public Boolean keyMatch, and we're going to define some behavior within. So here we'll have string key equals, paste in what we got from GRC. And then we're going to get an enumerable string of header values. We're going to do a filter string.empty. And go ahead and bring in an if statement here. So what we have are the HTTP headers for the current request, and we're going to try to get a header named key. And we're going to test to see if that key contains this particular string. If it does, we'll return true, the key matches. Otherwise, we return false. It's just that simple. So we're matching up the key to return a true or false. We're looking at the request HTTP headers for this specific value. So now down inside of our methods, we can protect any method by saying if key match, execute the real code, otherwise return null. This simple methodology secures your API without any other complexity to integration points and trust and various other infrastructure. Admittedly, it's a basic level of security. If this client secret is known, then other folks could, of course, use it. But it puts something out there so that we're not doing an anonymous API that's open to the entire world. And there are times when this might be useful. It's a good technique to document. So here we have the project ready. We'll go ahead and build it and give it a test. Here we are in our browser again. If we do API hello, we're going to see a response of null. If we go over to Fiddler and issue our request again and inspect the response, we see JSON null. However, if we go over to Composer and we add a header named key and we paste in that client secret, we now get a response that contains 49 bytes. And you can see the size difference where these were the null request and the 49 is a valid request because it contains an HTTP header named key that matches up with the internal .NET code. If we inspect that response, we can see the text value here as well as the raw JSON. So, this provides a very basic mechanism, but it gives us some level of security where we're not doing an anonymous API on the internet. It's just all too easy to have those when you do file new project. I think this is a level of security that only takes a few seconds to implement, but it provides a mechanism that only users who know the key value are able to execute your API. Thanks for watching.